There are certain topics that all technology business leaders should be aware of in order to manage your teams effectively and also run your business in this new business environment. And one of those that's getting a lot of attention lately is the concept of Kubernetes and what it's bringing to business world. So what I want to do is tell you a little bit about Kubernetes in this video and let you know that it came from our friends at Google. They had this problem themselves. They have extremely large and complex data centers, and they needed a way to effectively manage all the assets that are in that data center and do so in an automated way. So they came up with Kubernetes really as an orchestration platform that helps them deal with these very complex and large data centers. They did this in 2014, and they were kind enough to release it in 2015 to the open source movement, so it's now part of the Apache Software Foundation. And really, this is an orchestration platform that helps business leaders dealing with large, complex data centers for deployment, as well as orchestration, as well as monitoring the entire system. So let me tell you a little bit about Kubernetes so you can understand the concept. Now, we all know about an application. We understand how that works. It needs some type of file system to run on. It needs a web server to run on. If we do it across multiple servers, it also needs a load balancer. Of course, in a more modern data center, most of those servers are virtual servers, and if we have all of these different servers, we will need a load balancer to work with it. And of course, to make all those servers communicate with one another, we're going to need to do it across a network that's there available for it. So wouldn't it be nice if we could take all the information and all the assets that's required to make a particular application run and just put it in a box, like set it up correctly, check the security levels that we wanted on it, configure it the way we want it, test it very intently, and make sure it's exactly what we want, and then just put all those components in a box, like a container, like a shipping container, something that's very common, that's known in the shipping industry with a nice format that everyone's aware of and can use. Now, we're going to have lots of these shipping containers in our environment, so we're going to need to give each one a way to be identified, like a QR code, if you will. Well, in Kubernetes, we call that a name tag. And the good thing about that is, once we have this fully configured in a container, we can then do a lot of different things with it, like move it around just as shipping containers do on the global environment. We can put it in any number size of ships, or data centers, if you will, that allows that shipping container to be shipped around. Now, of course, once we get these things in containers, in these shipping containers, we're going to need some type of orchestration platform to help them. So like a container platform, if you will. And one of the most popular ones out there today is Docker. And you can even see here, staying with this nautical theme, it looks like a boat. It's a whale shaped like a boat with containers on top of it. So in order to make this all work, we're going to need some type of platform, a common platform to help us orchestrate all these different containers of where they might go, like a container orchestration platform. And that's where Kubernetes comes in. Kubernetes can almost be thought of like the conductor in an orchestra. It's the one that actually allows these containers to be orchestrated, if you will. And there is a broadly known API within Kubernetes that is released for this API for this platform. And many times, if you do this discussion with a technical team on a whiteboard, you might see someone write Kubernetes as K8S, K at the beginning, S at the end, with 8 characters in between. Because Kubernetes is the Greek word for helmsman, like a ship's captain. And if you think of it in the container world, the ship's captain of these large container ships may not know exactly what's inside the containers, but that person is responsible for getting the container to the right place, getting it to the right port, getting there on time, and lots of different containers on the ship. And that's kind of the concept here. Kubernetes allows you to do deployment, it allows you to configure workloads, it allows you to work with organizational units within these containers across a very large ecosystem. Now that item goes into a container, but usually the application that you have running in a container does not stand on its own. It sometimes needs to connect to the intranet if it needs another set of information to make itself work, or maybe it might connect across the internet to work with a partner application or to receive information from a partner company that you might have, or even other applications that it needs in order to function correctly. So the great thing about this is once you get your particular application in its container, you got it working configured correctly, if it needs another container full of applications or connections or wherever it might be, you can put those two together in what we call a pod. Kubernetes has this concept of pods, and that actually brings 2 containers or more together in a set. And then once you get that pod set up and working, it can easily be replicated across the environment to make sure that the business component that you're trying to get done by this particular application inside the container can work. Now, of course, you're going to be doing that across the assets that are in your data center. The servers, the disk storage space, the CPU or the compute power that you have. And that could even be done in a modern environment in a private cloud. Now, of course, you may use a private cloud inside your data center to share the resources across multiple departments or areas, so you're getting the best utilization of those resources. But it doesn't have to be just internally. It could also be through the public cloud, like a vendor like Amazon Web Services. And of course, Amazon doesn't have just one data center. They have multiple data centers. So this gives a lot more capability of assets for which Kubernetes can utilize to make sure the things that are inside that container are working well. And the way it does that with a scheduler. Now, a scheduler is just a normal server, just like any of the other servers, but it looks out across the enterprise, across the network that you've given it to, whether it's inside your own data center, your own private cloud, or through a private cloud service provider like Amazon, and sees all the computing assets that are available out there. This is the master node, if you will. And this master can look across the entire enterprise for the various nodes that it has capability to, that you've given it access to, and be able to set those up and use those within its configuration model to make sure that the application inside that container is working well. And it'll do whatever you ask it to. If you say, I need to make this application extremely fast, it will spin up more computing power for you. If it needs to be highly scalable, it will scale it up for you. If it needs to be highly available, it will put additional servers and capacity needs, server storage capacity needs, closer to where the location may be, especially in a global deployment environment. Basically, it does what you've asked it to do with all the assets that it has within its disposal. And Kubernetes does this automatically for you, which is a really nice way to do this. And of course, it may not just be across one cloud service provider like Amazon. It also might be utilizing Microsoft's Azure platform, or maybe Google's platform. And that same master server, again, just a regular server in the configuration model, can look across this entire enterprise of cloud service vendors that it has access to, that you've given it access to, that you've told it about, and then spread things out in the most appropriate way, spinning servers up when you need them, spinning servers down when you don't, and using the best capabilities it knows through its technology to make the application do what you want it to do. Make it fast, make it scalable, make it highly available, whatever that may be. So you might ask yourself, well, then how does it look across these multiple vendors and across the internet? Well, the great thing about this is, since Kubernetes is open source, each of these vendors has offered a flavor, if you will, of Kubernetes. So Amazon has theirs, Google has theirs, and Microsoft Azure has theirs as well. And they all use this common Kubernetes standardized platform upon which to work. And so to make sure that's working, each company that uses Kubernetes, say across the internet or across multiple cloud service vendors, creates a storage key. This is a configuration model that you have used through, or you've set up through a trusted service on the internet that basically keeps a stored configuration that can be validated. Think of this as if you were to use your own personal certificate when you use something like DocuSign, and it validates your signature and your location from that storage configuration key. And the great thing about this is it allows you to see that across all the different various services that you have available. So the great thing about Kubernetes, again, it helps you scale these systems out. It helps you deploy them very easily. And the best part about it is it monitors throughout the entire system. So if one server goes down or one particular server goes down, it can spin up additional servers within its purview to be sure that those configuration models still continue to run. Again, Kubernetes is a great way for business leaders to be able to understand how they can get better usage out of their computing assets. I hope this video has helped you.